Hello students, once again you're welcome to Western University. Now we're in chapter 9, section 5. So this section will be looking at configuring RIP and RIPv2. So we're going to look at how to configure the routing information protocol and the routing information protocol version 2. So without much ado, let's begin. Okay, let's see if we can take our usual color. Okay, now routing information protocol. Routing information protocol is an example of a distance vector routing protocol, and a distance vector routing protocol is an example of a dynamic routing protocol, right? So let's begin to look at it. This preliminary we talked about in section 4. Routing information protocol is a dynamic routing protocol, right? Which means that the routers can periodically exchange their routing informations or their routing table. They can dynamically exchange their routing tables every 30 seconds. Every 30 seconds, a router can broadcast the routing table or routing entries to the neighboring routers. Okay. That we also said previously that routing information protocol is classified as a distance vector routing protocol, and what it means is that a router uses what we call the hop count as the metric. For distance vector, a hop count is used as a metric. Okay, a hop count is used as the metric. Now the hop count is simply the number of routers the packet has to go through before it reaches its final destination. The hop count is the number of routers a given data packet has to go through before it reaches its final destination. Okay. Now, routing information protocol permits maximum of 50 hop count before it will resort to what we call the routing loops. If it exceeds 50 hop counts, meaning if the data packet is sent over 50 routers, then it means that a routing loop can occur as a result. A routing loop can occur as a result of this. Okay, so all this basic information we've looked at them in section 4. We say if this is router A, and it can go all the way up to 50 routers before the show looks back. It's set back to the sender. Okay, the receiver will send it back to the sender. So routing loops occur when a router forwards data packet back to the router that sent it to them in the first case. When, let's say, this router B receive data packet from router A, and this router B, instead of sending it onward to the final destination, this router decides to send this data packet back to the router A that sent the information in the first case. So such is called the routing loop. Such algorithm or such nomenclature is called a routing loop. Now, still on the routing information protocol and other distance vector routing protocol send a entire routing table to the neighbor routers at every regular time interval. So what happens in routing information protocol is that, or not only routing information protocol, any other example of a distance vector, they carry out the same mechanism. This same procedure is what is being applied to RIPv2, and any other distance vector routing protocol. Okay, like we say, a very good example of a distance vector routing protocol is the RIP, which is a routing information protocol. So what happens is that in this type of protocol, the router sends its entire routing table to its neighbor router. A router sends its entire routing table to its neighbor router at every regular time interval, let's say every 30 seconds. So that's a lot. We already talked about the problem this kind of arrangement will cause, that sometimes the routing tables can be quite large, right? So the routing table that is being broadcasted to other routers could be quite large, and therefore there will be a lot of issues with the network to consume a lot of network bandwidth. So, and hence there will be a lot of issue like laggy, delay, longer convergence time, and so on and so forth. So many other problems. Limited bandwidth, slow network, data traffic resulting from that, errors resulting from that. That's the reliability will be less, system reliability will be low or less because of these kind of problems. Okay. Now the default time interval for the RIP, the route information protocol for exchange routing table is 30 seconds. This is a default time. Every 30 seconds, the router will broadcast its routing table to its neighboring router or adjacent router. Okay, so because of this, there will be a slow route convergence, there will be slow convergence, and there will be multiple router sharing route tables. So many routers sharing same route table, and hence there will be longer convergence time. So the convergence time will be longer, so efficiency will be diminished, will be reduced. Okay, so this is exactly what we say. Like you have a campus network that has 3 routers. So the RIP system is that you broadcast this router, anything from this local area network goes through this router A, and router A has to broadcast to every router on this network. Every 30 seconds, every router will receive the routing table of the entire router A. B will receive, C will receive every 30 seconds. So that could result to bandwidth, slow bandwidth, because the capacity is full, and there will be longer convergence time, there will be slowness, there will be delay because there's a lot of data traffic and so on and so forth. So this is what we see in this kind of scenario, because this router A has to broadcast everything in its routing table to every other router on the system, and every 30 seconds they have to. So if we are using an RIP, if you are using an RIP, the routing information protocol, if you are using an RIP, which is an example of a distance vector routing protocol. So if you are using an RIP, every 30 seconds there will be a dynamic, because it's an example of a dynamic, despite it's a distance vector protocol, is an example of a dynamic routing protocol. So every 30 seconds there will be a broadcast of the routing table of the information in this router to router B, and to router C, and to router and any other router on the network. So this brings a lot of issues, and hence we have to find a way to solve this type of problem by looking at other means. Although the routing information protocol version 2 kind of solves some of the problems, but could address all the problems. Now let's take a look at how do we then configure RIP, how to configure RIP so that the system can be able to operate after configuration. How do we configure it? So what we do is, you look at the network. This is as an example of a simple campus network. Then we say we go to the global configuration mode, and then we begin to enter our command, okay, in the command line interface. We begin to enter our command in the command line interface by typing router config hashtag router RIP, meaning you are saying you should enable RIP in the routing information protocol. You should enable this protocol so that this router can forward any data packet through using this protocol, this means. Okay, so what we are saying by saying router config hashtag router RIP, you are simply saying that you should enable RIP to run on the router. This language, this command language, means that you are saying that the computer should allow RIP protocol to run on the router. That's the first. So this is the first one you type. The second one you put on your command line interface is to say router config router hashtag network 10.0.0.0. So what does this mean? You've enabled a particular network, because there's for RIP, after you put the RIP only work with same class. Okay, let's say for this, if this is class C IP address, then the IP address of this also has to be class C, because for RIP, if the class are different, then it will not work. We're going to show it. We're going to show it in our next slides. So RIP routing protocol works with IP of same class. So even if a LAN with an IP address from here should have, for the router to work with it here, should have the same should have the same IP address on this other router. So if the class of the RIP are different, we are talking about the class. The class of the RIP, you can see 10.10.20.0, this 10.10.10. So this same class. But if they are different class, so you have to, when you are configuring it in the global configuration mode or using your command line interface, after you put router config #router RIP, the next is to enable the class. Okay, you have to type the class command. You have to type the class command to enable the network to work with RIP. So router config router #network 10.10. Meaning anything 10.10.20.1 .10.10.10.2, they are in the same class. They are all in the same class. So meaning it's going to work with 10 class 10. Okay, of this IP address. Then what it means is that you have enabled the RIP network to be advertised. You have enabled it to be advertised. RIP uses a class network address. You see, it uses a class network address. Any IP address that doesn't belong to this class will not work with RIP. Will not work with RIP. So these two command language is enough for enabling RIP to run on your router, to the routing protocol to run with the routers. Is that okay? So just knowing these two commands, typing them in your command line interface, then you're good to go for RIP. Router config #router RIP, that's the first one. The second one is router config router #network. You define the class of the network that it has to work with. Is that okay? So let's move on to the next one. Now there's what we call contiguous network. That's the class. The class T is called the contiguous network. Okay, the class. Now RIP can only be used in a contiguous network. You only use RIP in a contiguous network. If there's a network that is discontiguous, any network that is discontiguous then cannot work with RIP, routing information protocol. So we say RIP can only work with a contiguous network, meaning that the network and the route must have the same class network address. Must have the same class network address. So if they're in class 10 or class C, all of them, the network and the route must all have that class C. Now this means that the router addresses for the network connecting the router must be same as the LAN connected to the router. So what this means is that the router IP address should be in the same class with the local area network IP address. Okay, the router's IP address, the routing protocol IP address, or the default gateway IP address should be same as the LAN, the local area network IP address. Okay, for example, let's see, this is what we're saying. This is a contiguous network. Take a look at these two diagrams. Now diagram A, you look at diagram A and diagram B. This is contiguous because this is a LAN, local area network. You see the IP address is a certain class, 10.10.20.0. That's the IP address or IP subnet of this local area network A. Now, if you take a look at the IP address of this link between two routers, okay, between the two routers, is also 10.10.200. So since it starts with 10.10, so this is a same class. It means this one will work. And look at the local area network B, also 10.10.10.0. So all of them conform. Is contiguous. Is what? It's contiguous network. This one work with RIP. So RIP will only work with a system put in place like this. A system where RIP work with a system where okay, RIP work with a system that has same class for both the local LAN, local area network, and the routing IP subnet. The routing IP subnet between the two routers and those of the LANs must be in the same class in order for routing information protocol to take effect, in order for it to work. In order for routing information protocol to work, then both the LAN IP subnet and the link, the hop count between the two routers subnet must be in the same class. Now take a look at the B, the second one, the discontiguous network. Discontiguous discontiguous network. Take a look at discontiguous network. The discontiguous network, you can see the IP is class C for the LAN here, 10.10.20.0 subnet, and look at the IP address between the two routers is in another class. It's like class A. It's a different class, 192.168.10.0. See, then they don't conform. This LAN conform with the first LAN A, IP address conform with LAN B in terms of class, but it does not conform with the IP address of that is between these two routers. Okay, you know, this is a router, this is a symbol of a router. We've defined this earlier in our previous class chapters. This is a symbol of a router. So you can see that this router and this router, the IP address between them of the IP subnet mask between them is way different, is in a different class compared to the IP address in the two LANs. So this is a discontiguous network, discontiguous network. So RIP will not work here. No RIP. RIP protocol cannot work here. No RIP. RIP protocol cannot work. No RIP for this one, for a discontiguous network. But for a contiguous network, yes, RIP can work with a contiguous network because both the IP subnet of the two LANs and the between routers is same. It's in the same class. Okay, let's move on. Now let's go to how to show IP protocol. We've already showed the command line, the command for configuring the RIP protocols. But how to show it, how to display it. After you've typed it, you want to see what you've typed. So what is the command line that you need to show the IP protocol with RIP? The command that you need to type on the command line interface in order to display what is already showing, what is already configured. So the command is router A. You have to define which router you want to see. Router A hashtag IP protocol. So you have to type it like this. Router A, because you want to see hashtag show. You have to tell it to show. Show, the abbreviation is SH for show. Show IP protocol. So once you type this in on your command line interface, the display will pop up. All this display will come up. Routing protocol is RIP. So it's telling you that the routing protocol is a RIP. That's what it's telling you. It's telling you that the routing protocol is RIP. Right? And then it's also sending update every 30 seconds. It's telling you that every 30 seconds the routing table will be broadcasted to other neighboring routers. Okay, the next one is coming in the next 5 seconds. The next one is coming in the next 5 seconds. So it's display all this information for you. Invalid after 180. So it will become invalid after 180 seconds. Hold down is 180. Flush after 240. After 240, everything will be flushed off. Okay? So this is when you type the show IP protocol with RIP. So it's just to type this command. Router A hashtag show IP protocol. Router A hashtag show IP protocol. Then all of this information will be displayed. Now displaying the route information. Now how to show the route information? It's just you have to put the route. Where we put protocol just now, you have to put the route. Just now we say router A hashtag show IP protocol, right? That's how I show the protocol, that the protocol is RIP. That the protocol is RIP. If you want to see the route, displaying the route, what type of route, or which route, you write router, you define router hashtag show IP route. Router hashtag show IP route. So this is another command for showing the route that are available. So you show you all the routes. These are the codes. C for connected, S for static, and like that. So all these are displayed. So it's telling you the possible route with the routing. This enhanced interior gateway routing protocol is there. You have OPU shortest path first routing protocol is there. It's showing you every one of this routing protocol that is in the entire system. So all of them is displayed here. Okay, so with their abbreviation, their codes. Okay, T for traffic engineer route, U for per user static route. So it shows you all the codes and their meaning. So another thing that will be displayed when you want the route to be shown, you see the gateway of the last resort is not set. It's telling you that the gateway of the last resort. You know, we talked about the gateway of the last resort in chapter 9, section 2. That is always good to set the gateway of the last resort. The reason is that if there are packets that do not have a destination MAC address or destination scribe on them, then they will be forwarded to this gateway of last resort router that will eventually forward to the next router, to the next router, to the next router, till the packet gets to where it's supposed to be. Okay, so here is showing you the class C, or this particular class. Subnet is one subnet and directly connected. That is telling you 10.10.20.0 is directly connected, and this is the interface. Fast Ethernet, this is the speed. Fast Ethernet 0/0 interface. There is also telling you that it's a class C. Another class C, 10.10.200.0 is directly connected. Okay, well, because it's showing you the routes, all the routes that are available, and it's telling you the fast Ethernet 0/1, and then you say 10.10.100.0 is directly connected. Fast Ethernet 0/2. Now you can see them directly from the configuration, the campus configuration, the one we showed before. Okay, this one. It's telling you how they are available. They are available. Fast Ethernet 0/0, 10.10.20.0. This one, 10.10.20.0. It said this route is connected. The route is connected. The protocol is available. He has also spoken about 10.10.200.0. Fast Ethernet 0/1 is available, and then he has also spoken about this Fast Ethernet 0/2, which is 10.10.100.0. All these routes are available. Okay, that's what this one is saying here. This is what this one is saying here. When you say displaying the route information, it tells you all the routes that are available, all the routes to the destination that are available for the data packet. It's saying this route is available, so you can bring it on from here to the router, to this way is available, and to this way is available. All the routes where the data packet can leave this router are available. 3 routes, 1, 2, and 3. They are all available for this router A. So that's what when you type the command router hashtag show IP route. When you say show IP route, all the routes that are available for data packet to go through will be displayed. Okay, let's displaying the running configuration. If you want to see the running configuration, just type router A hashtag show run. Router A hashtag show run. Once you type this in your command line interface, type this command, then it will start building the configuration, and then it show you router RIP is running. The route information protocol is running, and it's telling you the network class C network is what is also available. So it's showing you displaying the running configuration. It's showing you the protocol the routers are using and the class, the protocol and the class. This is what this one is displaying. Okay, now let's take a look at a bit of RIP summaries. They say RIP is relatively simple routing protocol. It's a simple routing protocol to configure. We already put 2 languages to configure them, command languages to configure them, and about 3 or 4 languages to check what is running, what is going on, like the route, to see the protocol that is running. There's a command to see the protocol, there's a command to see the route, there's a command to see what is being configured, what is running, to display the configuration that is running. Okay, there's a command to display the route, like we said, about 3 of them like this. Okay, so it's easy to configure and it's easy to see what is running. So RIP, we say it's simple routing protocol, is very easy to configure. And RIP is also, which is route information protocol, is only good for very small networks that have limited staff size to manage the network. So you don't use RIP for large network, just a small network with small number of staff. to manage, then you can use the RIP protocol. Now, RIP, which is Routing Information Protocol, is not suited for networks that needs fast convergence, that needs fast delivery, okay, of data packet. If you're looking for a network that needs fast delivery of data packet, you look at Open Shortest Path First Routing Protocol or Enhanced Interior Gateway Routing Protocols. Okay, so not RIP. Although RIP version 2 is way better than RIP itself, but still has its own, still has some limitations or some problems that's yet to be addressed. So RIP is a standard protocol. Okay, the good news about this is a standard protocol. It's not a proprietary protocol. What we mean is that it can work with any system. It's not like, for example, if you're a proprietary protocol, it means that maybe you are customized. Like Cisco customized protocol is Enhanced Interior Gateway Routing Protocol. Okay, this is the customized one for Cisco routers. For all Cisco routers, the proprietary protocol that they use is Enhanced Interior Gateway Routing Protocol. Okay, but RIP is a standard protocol, meaning it can be used by different manufacturers. You can take Hawaii routers or Cisco routers or Intel routers. Any other router manufactured by other vendors can use the RIP. You can configure the RIP language on it. You can configure the RIP protocol on it because it's a standard protocol. It's not a proprietary protocol. By proprietary protocol, we mean a vendor-specific protocol, a vendor enhanced or enabled protocol. Okay, therefore, the use of the protocol is not limited to certain equipment manufacturer. Why? Why is RIP not limited to certain manufacturer? Because it's a standard protocol. So this is a good advantage RIP has. It's a standard protocol, can be used by all vendor or all manufacturer. But one disadvantage of RIP, especially the RIP version 1, it does not support VLSM. VLSM is a variable length subnetting mask. VLSM is a variable length subnetting mask. RIP, especially the version 1, does not support this VLSM. But the version 2 now supports the VLSM and many other things. Is that okay? So let's take a look at the example. Well, this example will show RIP's limitation. This example we're about to look shows some limitations or some things that make RIP look as if it's not so good. Okay? In this example, the subnet mask of the LAN C network will be changed to 255.255.255.128. Now, to accomplish the task, the fast Ethernet 1/0 gateway interface for router B needs to be reconfigured as follows. So if you want to configure, because you want to use, you've changed the subnet mask to 255.255.255.128, so you have to reconfigure this interface for B. Router B #config terminal. So meaning enable the terminal to be configurable. Okay, then you enter the configuration command, one by line, one command per line, and then till you reach the end, then you hold Ctrl Z. Now router config #interior. Then after you enable the terminal, the next command, like we learned in chapter 8 or 7, the next command is to write router config #interior. This int means the interface fast Ethernet 0/1. You know, this is there for router B interface 0/1. Then you now write router config interface #IP address 10.10.1.250. You put the IP address, you configure the IP address for the interface, and after you put the IP address, you have to follow it with the subnet mask. The subnet mask in this question, in this example, which is 255.255.255.128. Okay, so you start by configuring the terminal. Router B #config terminal. Then you say, you go to another line, click enter, you go to the next line for this second command. Router config #interface fast Ethernet 0/1. This is the second command. This is the first one. Okay. First, this is the second command language, or the second programming language for the protocol. Then the third one is this one. Router config interface hashtag IP address 10.10.1.250. Then you follow it. The next line, or the last one, this is the third one. The last one you follow with the subnet variable length subnet mask. You follow it with this one. This is the fourth one. You just put the variable, only the variable length subnet mask. You just follow it with this. Is that okay? So when you do that, then you will get this router B running. Okay. Now what we will notice is that since the RIP does not support VLSM, what will now happen to the newly reconfigured subnet? Because RIP protocol does not support a VLSM like the subnet that you eat doesn't support it. So what will happen to it? It means it will not recognize it. Since RIP protocol does not support VLSM, it will not recognize the subnet 255.255.255. It will not recognize the whole thing that you've done. It will not recognize it. So it will not see it. Because it does not support it. It's not its fault. It does not support it. So it will not see it. Except you are using version 2. Except you are using version 2 RIP. If not, if you are using version 1, it will not see it. So the answer to the network 10.10.1.0 will not be advertised. You see? Why will it not be advertised? Because it will not be advertised by RIP, Routing Information Protocol. It will not be advertised by Routing Information Protocol. Because you cannot see it. It does not see any variable VLSM that is broadcasted. So the route for the network 10.10.1.0 is not will not be displayed in the routing table. It will not be displayed in the routing table of router A as shown with the command show IP route. Now, let's take a look at this command. If you type this command show IP route, we will not this one will not be displayed. Okay, this network 10.10.1.0 will not be displayed because it does not recognize the VLSM that goes with it. Okay, for router A, it will not be displayed. Is that okay? So router A hashtag show IP route. Router A hashtag show IP route. These are the code. These are everything. The gateway of last resort not set. This 10.0.0/24 and it has 5 subnets. It's telling you there are 5 subnets. Arrow for 10.10.10.0 120/1 via 10.10.200.2 and display the time, the fast Ethernet 1/0. The C 10.10.20.0 is directly connected. Okay, this one is directly connected for this one, for router A. And this one also is directly connected between router A and router B. But this one, you see, does not recognize it, does not see it. Okay, so this is what we're saying. But now let's take a look at version 2. Since version 1 has a limitation, the limitation is that it does not recognize VLSM. Version 1 of RIP does not recognize VLSM, the variable length subnetting mask. It doesn't recognize it. Excuse me. So to address some of the limitations that are posed by version 1 of Routing Information Protocol, then the version 2 was developed in 1993. That's quite some time, right? Version 2 was developed in 1993. So RIP version 2 is not quite a redesign of version 1. It's not a redesign, or it's not totally different. Everything is same, except that it could be taught more of an enhanced version of version 1. It's just an enhanced version. It's not a redesign. They're just trying to enhance it and make it to support some of the things that the version 1 could not support. And some of the things the version 1 could not support is VLSM. Not only VLSM, even CIDR. Version 1 could not support CIDR. Route authentication could not support route authentication. Okay. Also Nest hop specification, specifying the Nest hop. Version 1 could not support it. But the version 2 has addressed some of this problem. So RIP, Routing Information Protocol version 2, works basically just like RIP version 1. They work almost the same way, but except that it has introduced some features, some new features, such as it supports VLSM. It supports VLSM. The version 2 supports VLSM and CIDR. That's one. Then it also helps in route authentication. Can authenticate a route. Okay, that this route is free, you can send. Then also it helps the Nest hop specification. Can help to specify the Nest hop where the data packet can route through. Then it also helps to determine the route tag and also use the use of multicasting. So these are some improvements that we have brought into the Routing Information Protocol version 1. Okay, the version 2 has brought all this improvement. It's able to support VLSM and CIDR. It's able to help in router authentication. It's also able to help to specify the Nest hop. It's also able to help to route tags and also use of multicasting. So these are the benefits the improved version 2 has brought compared to the version 1 that we earlier had. However, it still cannot resolve some of the limitations found in version 1. So it's not all the problem it could resolve. Those are the hop count limitation. Could not resolve the hop count that version 1 has already posed. The version 2 could solve that. And also the metric decision. These two are big things that the RIP version 2 could not address. But version 4 and version 6 hope we can come up with version 4 and version 6 will be able to solve this limitation. Although there are other versions like Enhanced Interior Gateway Routing Protocol and the Open Shortest Path First Routing Protocol are able to resolve these limitations. The hop count limitation and the metric decision are solved with all these link state vector routing protocol. Okay. Now, configuring RIP version 2, the Routing Information Protocol. The configuration is same like the RIP version 1. The steps are same to configure version 2 are almost exactly same as 1. Just that we have to specify version 2. Finish. The only difference is the version. Okay. You have to specify where you just write RIP, you just say RIPv2. Okay, RIPv2. So you have to specify the version must be specified in the router RIP configuration. So in the configuration language, you just put version 2. Where you only write RIP, you now write RIPv2. RIPv2. This is what you include. So the next step to configure RIP version 2 is to issue the command version 2. You must put this command. You must add it to the command interface. Without specifying the version, it will become version 1. RIP version 1 will be used by default. If you don't specify RIPv2, you just configure RIP, it will be, by default, it will be RIP version 1. So you must specify when you are typing the command. Okay, so finish. These are just the two steps that you need to take further, just to specify the version 2. Every other thing we used before is same. Okay, so to verify, that's for configuration. Now to verify that RIP version 2 is the running the routing protocol, the command show IP protocol will be used. Anytime you want to verify, show IP protocol. Okay, router, you must put the router you want to see the IP protocol. So you say router A hashtag show IP protocol. Then you say routing protocol is RIP. And then it defines every 30 seconds, it gives you every other information. The next hop count will be 17. If value is after 180, flush is this, and so on and so forth. And then you can see here default version control, set version 2, receive version 2. So it will be displayed here that is version 2 because in your command you have included version 2. So it's telling you that is the version 2 that you have sent and what you have received. Now, still of version 2, now let's re-examine the demonstration of RIP version 1 limitation, where the VLSM was being used and where the subnet mask for the network 10.10.1.0 was changed to 255.255.255.128. Now, with the RIP version 2 enabled, once you use this RIP version 2 enabled, the command show IP route is reissued at the router. This time, the routing table shows the LAN C network 10.10.1.128/25 being displayed. So you now see the class C is displayed. LAN class C is displayed, not arrow like in the first case. Okay, even though it has a different subnet than the others. Look at it. 10.10.1.128/25. Okay, via 10.10.200.2. So this is displayed. Okay, even if it has a different subnet. So this one will now be displayed. 10.10.1.1.128 is now displayed. Okay, remember all you did was to enter 255, the subnet. Now meaning it recognized the VLSM 255, not 225, 255.255.255.128. So meaning it's recognized 255.255.255.128. So because of this subnet mask, variable length subnet mask that we have entered is able to recognize it here, 128. Okay, so it means that this class C, this particular version 2 recognize this class C route. Okay, now networking challenge. You open the textbook if you bought the textbook. There's a CD on RIP challenge provided with the networking challenge software. So open the CD and type the commands that we've mentioned or that we've itemized and see how it runs for a virtual simulation for routers. Okay, so with this we come to the end of our section. Here we looked at words like RIP, which means routing information protocol. We talked about routing loop. We talked about advertise, classical addressing, class network address. Okay, when we were talking about 10.10.10.1 show IP protocol, the command we use for the protocol. If you want to see the protocol that is running, you should router A hashtag show IP protocol. It will display the protocol that is running, that the protocol is RIP, and then if it's version 2 that you've configured, it will also show you that it's version 2 protocol. All of this we've taken a look at them. So with this we've come to the end of our today's section.